So I'm going to go over a couple things here in this video. We have some basic things I will introduce, but the topic of this video is going to be covering fractions, and particularly solving equations with fractions in them. So a couple things that this video is going to have that you need some prerequisite knowledge of is going to be a couple of things. So on this page here you see a couple of things you need to know are inverse operations. So I'll be talking about a couple of these throughout the problem. Um, so first one is your inverse operations. What are your basics? Well, one of your basics is multiplication and division are inverse operations. So essentially what they will do is that if you have a number that you're dividing by, if you multiply by that same exact number, they will effectively reduce each other out to 1. The other inverse operation, which isn't talked about as often, but which is a extremely useful property, is multiplication and multiplication, but with a reciprocal. So multiplication actually is undone also with multiplication with its reciprocal. So that's an important property to know, and I'll be using that especially because this problem I'm dealing with fractions. And most of the time, when you're doing multiplication and multiplication with a reciprocal, it mainly has to do with fractions. The last one is going to be addition and subtraction. So if I say add 2 and then I want to undo it, so like I never added 2, I just take the 2 away, which is done subtraction of 2. The next thing, some basic properties. One, any number. So I'm down in this particular spot right here, which is a divided by a equals 1. So any value divided by itself is 1, which is important, mainly because a lot of the times we're going to have a variable that has a coefficient or a number in front, and we want that number to become just a 1, so we want the coefficient to become a 1, so therefore how do you make a coefficient become 1? You literally divide it by itself and you get the value of 1. So the next thing is another basic property. So this next property that I have here below that one is going to be called the additive inverse property, which claims that if I take a number and I add its opposite, it makes the value of 0. So that's also important because when dealing with equations, what you need to recognize is that we are going to be trying to make 0 because we're going to be trying getting rid of values from one side to the other. The next one is this idea of some number sense. So the number sense is if I have a number and I'm subtracting a number from it, okay? So if I do a minus a, all right, I want you to understand that is the same thing as if I wrote that as a plus negative a. So a minus a is the same thing as a plus negative a. That will be important when we get into problems that involve something called the distributive property. So reciprocal rules. So reciprocal rule. So much like we had this number divided by itself that gave us 1, sometimes our coefficient isn't a nice number, and meaning it's not an integer. So this rule right up here in the basic properties is mainly talked about when you're dealing with integers. So if I have like 2 or -5 or 7 or -3, all those nice numbers that sometimes teachers use, as integers, when you have this property, when you do a number divided by itself, generally we will use this rule when we have integers. However, if our coefficient of a variable is a fraction, okay, notice we can make 1 the same way we make 1 above, but down here to make 1, what I'm going to actually do is I'm going to take the fraction and I'm just going to multiply it by that fraction with its numerator and its denominator switched. And lo and behold, when I do that, I create the value of 1. So this is the idea of multiplication with a reciprocal will undo a number that is already multiplying something. The last thing we're going to deal with is some basic grouping symbols. So a lot of people don't understand grouping symbols, but grouping symbols are anything that require two things to be grouped together in the sense of they get locked in together, which there is a higher power, a higher operation, I should say, that is linking these two things together. So if you have a lower operation that is being connected somehow, some way through another one, of operation that is greater than it, then it becomes a group, i.e. fractions can become grouping symbols. So why can a fraction become a grouping symbol? Because if you have a fraction that has a addition or subtraction in either its numerator or its denominator, that addition of those two values is locked in as a group until the fraction is gone. So grouping symbol. The next one is the common one that everyone sees is parentheses. So, sorry about the long introduction, but here we go. Let's go ahead. So, first problem I have here for you says 1/3 x plus 2/5 equals 4x minus 1/8 times the quantity of x plus 4/5. So, what I have here is my first group. Now, in mathematics, what you need to understand is you've been taught a very, very long time that grouping symbols are the things you must look at first. So I'm going to do that here. I'm just going to naturally gravitate towards the group. I see the parenthesis, and the first place I look at is inside the group. And I notice I have an x plus 4/5. Well, there is nothing that I can do here because what we call these in math are unlike terms. And a term is being defined as being like so long as all of the variables and their powers are identical. So this value is an x, this value, I don't need to say that it's a number, it's not important. What's important to notice is this does not have an x with it. So because this does not have an x and this does, I look at them and I go, I cannot combine them together into some new value. So because I can't do that, the next place I begin to look is I always look up here. I look up at this value here to see if there's an exponent attached to the parenthesis. And what I notice is that there's no exponent attached to the parenthesis. The next place I look is out front of the parenthesis. And why do I look out front of the parenthesis? Is because any number that is attached to the front of a parenthesis, okay, means with no mathematical symbol between it, means that this value in front of the parenthesis is attached to this group through the property of multiplication. So what I begin to notice here in this problem is I have multiplication. I have multiplication of a group. So in the order of operations, because I have a group and multiplication attached to it, generally speaking, we will take care of this multiplication first prior to moving along with anything else in the equation. So what we're going to do is we're going to go ahead and do that. So one of the things you just have to be careful of is one of the properties that I talked about before. Do you see how this says 4x minus 1/8? A lot of times people make the mistake of just distributing the 1/8 and they don't attach with it or associate that this is a negative because they read that as a subtraction symbol. Well, one of the properties we talked about off here to the left, I'm going to show you above, was that if I wrote a minus a, that was the same thing as me writing a plus negative a. Now, why is that important in this case? Because when it deals with multiplication, this negative symbol is attached to its value. So it becomes very, very important to understand is that minusing a number attaches a negative to its value. So when we do the distributive property, we just need to make sure that we are multiplying everything here by this value of 1/8. So we're going to multiply everything here inside this group by the value of negative 1/8. So what I like to do prior to doing the multiplication, I like to drop down everything else that is in my equation that is not attached to my multiplication. So what I will do is I will go back to the beginning here and I will drop down this 1/3 x because I'm not doing anything with it. So I'm just going to set up my second row. Equals. Notice I'm not doing anything with the 4x, so I drop it down, and now this is where I begin to finish off the rest of my sentence. I finish off my sentence by doing the distributive property. So negative 1/8 times x is negative 1/8 x. The next thing I do is I will take this value because it's distributive property. Distributive property claims that I must take that value and multiply it by each term within the group. So I will now take 1/8 and multiply it by 4/5. So negative 1/8 times 4/5. Now, if you don't have a calculator, then you'd have to do this by hand, okay? And I am going to suggest for this particular video, I'm just going to be writing down the answer here because I'm going to do the calculations in my head. But anyhow, at this point, if you struggle with fractions, I would suggest that you use a calculator for problems like this. Otherwise, if you're a person who's not allowed to use a calculator, then what I'm going to do is I'm going to show some side work. So the side work here is 1/8 times 4/5. Now, this is an easy problem for me to do because when I do multiplication, what I recognize is that it's numerator times numerator, denominator times denominator. Now, what I'm going to utilize here is a cool little trick called the Commutative property. The commutative property allows you to switch numbers around so long as they're being multiplied. So what I'm going to view this problem as is I'm going to view it as 4 over 8 times 1 over 5. Now, I haven't broken any rules, okay? Why haven't I broken any rules? Because when I multiply fractions, I would have done 1 times 4 and got a numerator. So me switching it to 4 times 1 in the numerator, it's not going to matter. It's not going to affect my answer. But what it does do, it allows me to do something kind of cool. It allows me to reduce this fraction. And it allows me to reduce it as 1/2. And now I'm really doing 1/2 times 1/5. And why is that important? Because now my multiplications just simply become 1 times 1, which equals 1, and 2 times 5, which becomes 10. So it's a neat little trick to do. You get, as you do more and more of them, you would become quicker and quicker at them. But if it's something you don't practice with a lot, doing this property can get a little confusing, but either way, all right, for someone like me who's experienced in doing this, this is the way that I do it in my head, and this is why your math teacher seems like they can do all these things so quickly, because what they're utilizing is something called the commutative property when multiplying fractions. They're switching the numerators and denominators around so that they can simplify their fractions to make it easier, and they're doing the calculations in their head. For instance, okay, I would not write any of this work out. I would literally just go in my head, I would switch the 4 and the 8, and I would do the work up here. I would look at this as 4 divided by 8. I'd cross off the 8, turn that into a 2, and the 4 into a 1. And then I would do the math within the problem. So 1 times 1 is 1, and 2 times 5 is 10, and I end up with that same answer of 1/10. So what I now have is just remembering that it's a negative 1/8 times a positive 4, so 4/5, which is a negative 1/10. So, sorry to do all that side note during the problem, but sometimes I view it as important to go over those things, so I just wanted to take that time to do it there. So, anyhow, continuing on with the problem, I have this value now, it's simplified. So, I am a person who likes to just work with fractions of the problem. Yes, there are other methods you can do, such as clearing the fraction, but at the end of the day, for a problem like this, at the Algebra 1 sort of level, or the introductory like review of Algebra 2, I am not a fan of using clearing the fraction. I think it's more work than you need to. I think you do more multiplications. It creates more mathematical error. So what I would rather do at this point is I would rather just simply do the problems straight out, either utilizing a calculator. If you can't utilize a calculator, and you got to do it by hand, then basically you just got to know your fraction rules, and we're going to go through that. So here we go. So in this equation, we've created this next step. And now what you need to understand is a lot of teachers will talk about this idea of combining like terms. What I want you to understand when we're talking about combining like terms, okay, we are not looking across the equal sign. So there's the equal sign right here. I am not looking across that. I am looking on either the left-hand side of this equal sign, or I'm looking at the right-hand side of this equal sign. So what I mean by that is, if I were to go ahead and take a look at this, right, here's my equal sign. I am looking over here at this group. This side of the equal sign is a group, and the group has a 1/3 x and a 2/5. So because this has an x, this does not, I can't combine them. So what I then do is I go over to the other side and I say, okay, do I have any like terms? So when we talk about this idea of combining like terms, we are not talking about this x and this x because they're on opposite sides of the equal sign. So when we talk about this idea of saying, hey, do you have any like terms that you can combine? The answer is, for this problem, yes. But the only reason that the answer is yes is because of this x and this x here. Notice these two x's are both on the right-hand side of the equal sign. So when we talk about combining like terms, you don't have to change signs. Combining like terms is just going to be read the problem as it is stated within the context of the problem and do the operation. So this problem reads as 4x minus 1/8 x. So I am going to do exactly that. I'm going to take 4 and subtract 1/8 from it. So what I'm always a fan of is I'm a fan of always setting up my next line. The left-hand side I haven't done anything with, so I'm going to write 1/3 x plus 2/5 is equal to, now I'm going to do this combining of like terms. And again, I read it as 4 minus 1/8, and 4 minus 1/8 okay, is going to be the answer of 31 over 8x. Now, I did that in my head very quickly, all right? I didn't use a calculator, and the way you can do this, if you learn to do this kind of quickly, is all I'm doing is making common denominators. Now, I obviously have more skill and have been doing this a little bit longer than others, but if you need a calculator, then go ahead and use the calculator. Otherwise, the side skill to that is learning to do it with common denominators. So 4 as a denominator of 8 is written as 32 over 8. So in my head, what I then did was 32 minus 1 and got 31 over 8. So I finished this off. Now that I've combined those two like terms, I'm going to put down here the minus 1/10, and the minus 1/10 is not part of it, so I don't combine it. So now all of my like terms have been combined. So at this point, I no longer have like terms that can be combined. And what I'm now going to do is I'm going to start using what we call properties of equality. And properties of equality are properties of numbers that we place. We add extra value into our equation so that we make values that we don't want there to go away. So, couple of games of solving an equation. So when you have equations that are talking about one variable equations, usually what the goal is to get variables on one side. So in equations, ironically, to make variables on one side, what you do is you turn one side into 0 variables. So how do I turn something into 0? Well, you turn something into 0 by doing its additive inverse. So that means if I have a positive number, I place with it its opposite. And then what you do is you go ahead and you make 0 out of it. But what that then does require you to do is, because you're in an equation, you have to do it equally on the other side. So the value that you actually use to make 0 on one side must equally be placed on the other side. That's the idea of a property of equality. It's this idea of what you do to one expression must be done to the other. So in this case, what I'm going to do is I'm going to go ahead and I'm going to make 0 out of this 31 over 8. And the way I do that is I write a minus 31 over 8, and I place it with an x with it because I'm trying to make the x's also go away. So I want 0 x's. I don't want any x's, period. So again, because I place this in to the right-hand side expression, I must equally give the left side expression the same exact thing. So now generally what we will do is, if we notice that we have a like term, we will do math vertically and we'll write it underneath the like term that it's matched with. So in this case, when I go over here, I'm writing minus 31 over 8 directly under the x, simply because, all right, that particular value is something that now is the same. So 1/3 minus 31 over 8 is not a friendly number to have, all right? So this problem is not going to become easy. So either way, what you end up getting for this problem is going to be, when you do 1/3 minus 31 over 8, is going to be 24 over 85x. So it doesn't turn out nice. It's not exactly the nicest thing in the world, okay? But that's what you end up getting. You get 24 over, oh, sorry. I wrote that backwards. That ends up being 85 over 24x, my bad. So this becomes 85 over 24x, and it is also going to be a negative 85 over 24x. So what I do now is that this value here, the subtraction of those two like terms, made this awful fraction below. Now, if you got a calculator, use the calculator and plug it in. I did some quick math. I turned the bottom into like denominators, so 3 and 8 have a common denominator of 24. So the next thing I have is that this 2/5, okay, which sometimes fractions can get confusing because yes, you have a lot of numbers, so don't get lost in that. That 2/5 has to drop down, so I'm going to write this plus 2/5. I don't want to lose track of the equal sign. There it is. And then I have this negative 1/10 over here. So why is it negative 1/10? Because when you subtract a number, it's like adding a negative. So it doesn't make this sign go away. Because I crossed out these two numbers, that negative still has to go down. So what I'm still trying to do now is, the name of the game is I'm trying to have x's by themselves on one side. So the issue is that I've got x's, but these x's also have an addition of 2/5. So I need to make the addition of 2/5 go away. Well, how do I do that? Again, we utilize the additive inverse property. And the additive inverse property states if I have a positive, I place with it its opposite, and it makes 0. So the goal here is to make 0 out of this, so I do minus 2/5. So this expression is increased by doing a subtraction of 2/5. So if the left-hand side I do subtraction by 2/5, I must go to the right-hand side and I do subtraction by 2/5. So what I now have, left-hand side, those 2/5 both cross out to make 0. They do cancel. And I'm now left with negative 85 over 24x equals. Now, I'm going to do this mathematics here. So negative 1/10 minus 2/5 ends up being negative 1/2. So my last step here, when I have a fraction, right, we talked about generally, like a lot of you will always see that this number in front of x will be an integer. It will be like a 5, a negative 3. And your teacher will say to you, hey, just divide by the value that's in front. Well, I, in this case, don't want to do that. And the reason I don't want to do that is because I don't like creating complex fractions. A complex fraction is when you take a fraction and divide it by another fraction. Because mathematically, I can't do that. I can't do that in my head. You can't divide fractions by themselves without converting them into a new property. So what I'm going to do is my goal is to make this a 1x. So the way I can make it a 1x is the property I talked about in before, which the property before is, okay, if I have a number, if I multiply it by its reciprocal, what it does is it creates the number 1. So what I'm going to do is, as opposed to dividing by another fraction, I'm going to multiply it by its reciprocal. And the reciprocal is just taking the numerator and the denominator of any number. In this case, take the numerator of 85 and the denominator of 24 and switch them. So the numerator of my new number that I'm multiplying by is now going to be negative 24 all over 85. Now, because I did multiplication that way, I must go and enter it on the other side. So I go negative 24 over 85. And now I'm almost done. The right-hand side reduces to be 1x. So that is now going to be equal to, and now I'm going back to the property of multiplying two fractions. So again, when I multiply these two fractions in my head off to the right here, I'm looking at this as negative 24 over 2. Okay, so I'm switching the numerators around, and I get 1 over 85. Well, I now know, so switching them around, and I get this 24 over 2 reduces to negative 12 over 1 times negative 1 over 85. So the work that's now being done in my head, again, is negative 12 times negative 1, which is 12, and 1 times 85 is 85. And right there, I look at it, and I go, okay, great, I am done. Now, I do know that this problem doesn't reduce, so I know that there's nothing that goes in the 12 and 85, so I know it's done. So it's not a pretty number, but what I will say to you is that within time, if you continue to practice these do get a little bit easier. However, there are a lot of properties that went over this problem, so I hope this helps if you're doing anything with fractions. But again, remember your best friend is going to be knowing your properties and knowing your inverse operations. The numbers aren't necessarily a big issue if you have a calculator. Otherwise, you will have to learn how to do your fraction skills. So for this problem, while I didn't do it with a calculator and I did do it by hand, okay, if you are a person who has a teacher that allows you to use a calculator, you don't have to worry about the numbers per se. You just need to worry about your inverse operations and the things that allow you to make zeros out of your numbers so that you can switch them from side to side. So I hope that helps with whatever you're working on. And yeah, let me know. Thumbs up, leave a comment. Let me know what you think about the video. I know sometimes my videos are a little long. But I apologize. I just want to do my best to explain that I can. All right. So have a good one. Thank you.